So Newton's laws of universal gravitation, right? And this is number 3. So I'm not going to do the number bit because you guys all know how to use a calculator if you don't come and see me. But let's do the formula bit. So the formula to start with is I got the cap in. The cap in. FG equals what?
GMM divided by R squared.
GMM over R squared is correct. Well done. Now, this question doesn't ask for the force, gives us the force. And then it says this, which is very important, equal masses, right? So we can change this a little bit, right? How can we change this if the masses are equal?
Let's make it M squared.
Good. So these two m's are now the same. So instead of GMM, it can be GM squared because the masses are the same, so it's mass times mass. So if there were 4 times 4 is 16, 4 squared. But this is only if m equals m. So if the two masses are equal, you can make it like this. Now, how are we going to solve that for the individual mass?
Divide by G times by R squared, square root of 4.
Okay, so we're gonna take the R squared, move it up here, and the big G we're gonna put down there. Yeah?
And then square root it.
Okay, and so we're gonna end up with Fg, the force of gravity, times big, no, not times big G, times R squared over big G. That's just simple algebra. And then we end up with m squared. Now we're not finished yet, though, right?
Square root.
So now we got to square root both sides. What happens to this square root and square?
It's rid of it.
It's gone because square root of anything. Squared is to be anything?
But what about the R squared? Does it leave? Or
No, the R squared you have to keep, well, actually, yeah, technically you could. No, it won't make a difference. It should be the same. Whether you square this, multiply it all out, and then square root it,
Isn't it
because
just-
there's no adding or subtracting in here, you can actually separate the square roots into these different parts. So you could say it's square root of FG over the square root of big G times R. You could do that, but it's not, it's kind of not much of a time saver. So you plug your numbers in there and you should get, what's the answer?
1.86.
1.86?
No, 186 kilograms.
186 kilograms. Okay. So if you plug your answers, your numbers in there, you should get this. If you're having trouble with this part of it, do some practice and do some Googling and bring it to me if you can't figure out the numbers on your calculator.
Can we
This
do-
is scientific notation, so use the capital E's for this, right? Put in the, whatever your calculator has, EXP button, or times 10 to the power of X button, or capital E's button. Use that to input that.
Can we do 11?
11 I've already done. I've made a different video for that, but I will, I can show it to you if you want. But we were gonna do, someone said 4 as well,
I
right?
said 4 too.
Do you want 4 too?
Yeah.
4 as well?
Wait, if it always says that it's like on the surface of the earth, like above, you always have to use like the mass of the earth, right?
Yes. So the gravitational force on an object from the Earth, that's, you are actually looking for force this time. So we leave our formula alone. The tricky part about this is the R, right? So can you just put the radius of the Earth here?
No, you have to add the
No. You have to have the radius of the Earth and add it to this. If you're watching the video and you can't remember, what's the mass of the Earth?
5.98
24 kilograms. What's the radius of Earth?
6.38.
Times 10 to the 6 meters. And what's big G?
6.67.
Times 10 to the negative 11.
Do you ever have to memorize these numbers?
Yeah.
I'm not going to make you memorize them. I'll put them on the test. But if they're familiar in your mind, it's going to make things quicker. So the more you deal with them, the better, probably. What is, if I put these three numbers into this part, what do I get? What number?
9.8.
9.8, right. That's what it said. Okay, so we have this number plus 6.38 times 10 to the 6. Those two numbers added together will be your R. Okay, and then you just have to put it into your calculator. The rest is pretty simple. The little m is the 650 kilograms of the object. What's the answer?
200 or 2,330.
I got 3.6 times 10 to the negative 11. I don't know what I did wrong.
That doesn't sound right.
Yeah.
What is it? 223?
2,338.
Thank you. Newtons?
Yes.
Technically, I would have to round that to 2340.
No.
Because this is 3 sig figs and so is this,
I
so
thought we
I
were
would,
doing sig figs.
you should do that.
I thought we were doing sig figs.
No, I'm just saying I would have to do that. So the answer key might say this instead of 2338. Okay. Good? Your calculator thing? You have to try that and bring it to me if it doesn't
No,
work.
because I did all the other ones properly. It was just that one.
Oh, that's a
Maybe
shame.
I did
Oh,
it
maybe
wrong.
you just hit the wrong button or something. Okay, and number 6, we're going to do. Okay, so two objects with a mass of that produce a gravitational force between them of this. And what is the distance between them? Okay, so now we're solving for what?
R.
Now we're solving for R. So same formula, but, and this is where the trouble comes in. There's an easy mistake to make here. There's an easy mistake to make.
Yeah.
What you want to do, your intuition says, well, we got to solve for R, so let's get rid of the G and the M and let's put them both down here, right? Well, what's that going to give you?
R on the bottom.
Yeah, the R is on the bottom, so that's going to give you 1 over R squared. So you can do that, but then you have to flip the whole thing, both sides, which is fine, you can do that. Or, and what the way that my brain works, is I would say,
R equals.
I don't like that this is on the bottom. It bothers me, so I'm going to change it. What am I going to do with it?
Multiply it by.
Multiplied by
Yeah.
FG.
Multiply it by both sides, or just think, I'm going to move it up here.
And divide by
Just swap FT.
And then swap FG down here. FG, make it divide FG by both sides. There you go. And so R squared is going to equal what?
EMM over FG.
Good.
And
These two are the same, so we can kind of keep this M squared if you want to, but it doesn't matter. Because we know
FG.
them, and then this is FG.
and square roots.
Yeah, so now we want to find, if we want to find the R, we got to square root both sides again. But it's really the flipping over that's the mistake that's made most often. What's the answer for this?
0.85 meters.
0.85 meters, 85 centimeters, eh?
Yeah, I got 0.72.
How did you do that? Did everybody else get 0.85?
Yeah.
You must have a funny click on your
Yeah.
calculator or something. Maybe a funny rounding or something. Okay, that was 4 to 6 on the Newton's laws.